It seems like AI is just everywhere these days, right?
Yeah,
Like every time you turn around,
it really does.
there's some new crazy thing these AIs are doing, especially those large language models. And,
LLMs.
we've even been hearing about them trying to do things like mathematics,
Oh, yeah.
like really hard math problems.
It's so interesting, to see these headlines about AI solving complex math problems,
Yeah.
even winning competitions.
Right.
And you immediately wonder,
Yeah.
are they actually reasoning
Yeah. Are they? Well,
mathematically in the same way a human does, right?
yeah.
Or are they just, really good at finding patterns
Yeah.
and getting the right answer without truly understanding the concepts?
Yeah, it's one thing to get the answer, right?
Totally.
But like you were saying, are they actually doing math the way a person would?
Exactly.
Like when you think about high-level math,
Absolutely.
it's not about just getting the answer.
No, not at all.
It's about the whole process of proving it.
Right.
Like showing each step and why it logically follows. And that's why this
Phil
study,
was fascinating.
yeah, this study that we're diving into today is so cool. It looked at how some of these super advanced LLMs did on a really hard math challenge. The 2025 USA Mathematical Olympiad, or USAMO.
The USAMO.
Yeah.
That's not just any math test.
No, it's serious business.
It is.
Like, this is for the top high school students. And it's basically a stepping stone to that, like the big leads, the International Math Olympiad.
The IMO.
Yeah, the IMO. And the problems on the USAMO aren't just about, like, calculating stuff. They're all about proof. You have to write out these detailed logical arguments.
Which is exactly why this study focused on whether these LLMs could actually generate that kind of reasoning.
Yeah, not just getting the answer, but showing they understand the math behind it. And they had actual human experts grading these AI-generated proofs.
Yeah, it's a really important part of the study.
Totally. So our big question for this deep dive, like the core mission for today is, can these large language models really do this high-level math reasoning, or is that just hype?
Yeah. Can they prove it, literally?
Exactly. Let's break it all down, starting with this USAMO 2025, where all this went down.
So the USAMO,
Yeah.
that's, like you said, the high-stakes stuff. To even qualify for it,
Yeah.
you have to do really well on these other tough competitions, like the AE.
So these are like super smart kids already, and then they get hit with these problems designed to really push their thinking.
Oh, absolutely.
And the format itself is, not your average math test.
It's definitely not multiple choice.
Yeah, it's not.
6 problems, 2 days, all proof-based.
Yeah, it's pretty intense.
Yep, it is.
And to really get a sense of what these LLMs were up against, they included some example problems in the study.
Oh, yeah.
Yeah, the first one said, let K and D be positive integers. Prove that there exists a positive integer n such that for every odd integer n greater than n, the digits in the base 2n representation of enc are all greater than d. I mean, wow.
It's definitely a mouthful. And to break that down a little,
Please.
you've got number theory, different number bases, and you have to prove something holds true for all these variables.
Wow.
You can't just guess and check.
Right.
It's about constructing a logical argument step by step.
That's the whole point, right?
Exactly. And that's what we're trying to figure out.
Can these AIs do that kind of deep thinking?
Yeah. Can they really prove things?
And then there was that second example, problem 5, which was determine with proof all positive integers k such that 1n plus 1 multiplied by the sum from I equal to n of n choose I raised to the power of k is an integer for all positive integers n.
Combinatorics.
Yeah, a lot of
Algebra theory.
Yeah, like you got to find those values of k and prove why they're the only ones that work.
Those were just 2 of the 6 problems they gave. The other 4, they didn't include in the main paper,
Right.
but you can find them in the appendix if
Yeah.
you're really curious. But they were all that same level of difficulty. So we're not talking about simple calculations here.
No, not at all. So they really threw these LLMs into the deep end, and it wasn't just about getting the final answer.
Right. They wanted to see the reasoning, the proof.
So how did they actually test this? How did they judge the AI's thinking?
So they took a bunch of cutting-edge LLMs, and they had them each try to solve the problems by writing out full proofs in LaTeX.
LaTeX, that's like...
Yeah, it's like the standard way to write math equations and stuff digitally.
Makes sense. So
Yeah.
they had these AIs basically write out their thought process.
Exactly. And to be extra sure, they had each model try each problem 4 times.
4 times each.
Yeah, 4 times each. And then they gave these solutions to a panel of human experts.
And these weren't just like people who like math.
These were serious math people, former members of the IMO teams. Wow.
So they know what a good proof looks like.
Yeah, for sure.
And to make it even more rigorous,
Right.
they had 2 different experts grade each solution.
So like a double-blind thing.
Kind of, yeah.
That's really thorough.
Yeah, it had to be.
Okay, so they had these top-notch experts judging the AI's proofs. But did they just, like, wing it with the grading? Or did they have specific criteria?
Oh, no, they had very specific grading schemes for each problem.
Okay, so they really thought this through.
They did. They based it on resources from the math community, especially this website called Art of Problem Solving, which is super respected.
Yeah.
And of course, they had the expert graders review the schemes to make sure they were accurate.
So they were really trying to be fair and consistent.
Exactly. And each solution was graded out of 7 points, like in the actual USAMO.
Right.
They even gave partial credit if a proof was on the right track, even if it wasn't perfect.
Okay, so they really set a high bar for these AI models. What happened? Did they, like, blow everyone away with their math skills? Well, that's where it gets interesting.
Okay, I'm intrigued.
The results weren't quite what you'd expect from all the hype. All the LLMs, they struggled.
Really?
The average score across all the models was less than 5%.
Less than 5%?
Less than 5%.
Wow. I mean, you hear all this stuff about AI being so smart.
Right. But and even more than that.
Yeah.
Out of almost 150 solutions, not one got a perfect score.
So no AI aced a single problem.
Not a single one.
That's pretty wild. Which models did they test, by the way?
They tested quite a few. QWQ from Quinn.
Okay.
R1 from DeepSeek R1.
Got it.
Flash Thinking, which is Gemini 1.5.
Okay.
O1 PRO and O3 MindEye from OpenAI.
Right.
And Claude 3.7 from Anthropic.
Okay, so a good mix of the big players out there. And I think you mentioned there's a table in the study that breaks down their performance on each problem.
Yeah, table 1. It's got the average scores
Okay.
for each model on each problem, their total score, and even how much it costs to run each model.
Interesting. So we can even see like the price tag for all this AI math.
Right. And what's striking is just how low the total scores are.
Across the board.
Across the board.
So they're great at those multiple choice tests like the AM.
Yeah. On some of those benchmarks, they're doing amazingly well.
Yeah.
Almost human level.
Yeah. But when it comes to actually proving things,
it's a different story.
A completely different story.
Yeah, it really shows you that maybe the way we're training these models isn't enough for tasks that need that really precise logical thinking.
So it's not just about being smart, it's about being able to explain your thinking.
Exactly.
Yeah.
It's like showing your work in math class.
Right, you got to show your work.
You can't just write the answer.
Okay, so let's get into why these models struggled. The study talked about different types of errors the graders saw. What were they making mistakes on?
They basically broke down the errors into 4 categories. Logic, assumptions, creativity, and algebra arithmetic.
So like the whole spectrum of math thinking.
Exactly.
Yeah.
And figure 2 in the study shows which type of error happened first in each solution.
Okay, so what tripped them up right out of the gate?
The biggest one was logic.
Really? More than calculation errors?
Yeah. It wasn't so much that they got the numbers wrong, but that their reasoning was off.
So they might have known the formulas, but they weren't applying them correctly.
Right, like they were missing the bigger picture.
Do you have an example of that?
Yeah, there's one from Claude G 3.7.
Okay.
Where it proved something for a single case.
Yeah.
And then just assumed it worked for all cases without explaining why.
So it's like they saw a pattern and just went with it.
But in math, you got to prove those patterns.
Right, you can't just assume. And what about those unjustified assumptions?
Oh, those are a big problem, too.
It's like they just throw in an idea that wasn't proven.
Exactly. And then build their whole argument on that.
Like a house of cards.
Kind of, yeah.
Okay, and then there's that creativity thing, which is kind of a weird thing to think about for an AI, right?
Yeah, how do you measure creativity in a computer program?
Right, but they saw a lack of it.
They did. Most of the models would get stuck on one wrong approach and just keep repeating it.
So they couldn't think outside the box?
Not really.
Yeah.
But there was one exception, flash thinking.
Oh, yeah.
It did try different strategies, but very superficially.
So like a little bit of everything, but not enough of anything.
Exactly.
Interesting. What about the more like basic stuff? Were they good, at least the algebra and arithmetic?
Mostly, yeah. They can handle the calculations without needing extra help. But there was one, R1, that made more errors in this area.
So even the calculations weren't foolproof?
Not always.
And I think you said they even try using LLMs to grade the solutions.
Oh, yeah, that was a fun experiment.
What did they do? Like, give an AI the answer key and see what happens?
Basically, yeah.
Mm.
They took O3 Manini and Claude 3.7, gave them the grading schemes,
Yeah.
verified solutions, and even examples of how human graders had scored similar problems.
So they were really trying to teach the AI how to grade.
Exactly.
Did it work?
Not really.
Ugh.
Table 2 in the study shows the results, and both AI graders were way too generous.
Like they were giving out A's for everything.
Pretty much. They consistently overestimated the quality of the proofs.
So even with all the information,
Yeah.
they couldn't judge the reasoning properly.
Nope. It seems like that deep understanding of math is still a human thing.
That's pretty fascinating. And the study also had some interesting observations beyond just the scores.
Yeah, there were a few things that really stood out.
Like what?
Well, there's this thing they call answer boxing.
Answer boxing.
Yeah, because a lot of these LLMs are trained with reinforcement learning,
Right.
where they get rewarded for giving a clear final answer.
Okay.
They started putting boxes around their answers,
Even when they didn't have to.
even when the problem didn't ask for it.
So they were so focused on giving an answer
Right.
that it messed up their thinking?
Exactly.
Do they have an example of that?
There's one with QWQ
Okay.
on problem 5, where it figured out that any even number worked,
Okay.
but then it just boxed the number 2 and said that was the answer.
Because it had to give an answer.
It had to have that box.
That's so interesting. Like, the way we're training them is backfiring.
It can, yeah.
What else did they notice?
They also saw a lot of overgeneralization.
Like jumping to conclusions.
Yeah. Basically, they'd see a pattern in a few cases
Yeah.
and then assume it worked for everything without proving it.
So they were good at spotting patterns.
Right.
But not so good at the rigorous proof part.
Exactly. It's like they were relying on intuition
Right.
instead of logic.
Interesting. And did the way they wrote the solutions, did that vary a lot?
Oh, yeah. Some models, like O3 Manini and O1PRO,
Mm.
were pretty clear and logical,
Okay.
but others, like Flash Thinking and QWQ, were all over the place.
So some AIs are better writers than others.
It seems that way.
And it sounds like the OpenAI models were the best at explaining themselves.
Yeah, they were generally the clearest.
So it's not just about being able to do the math, but also being able to communicate it.
Absolutely.
So after this whole deep dive into the USAMO and these LLMs, what's the takeaway?
I think the big takeaway is that while LLMs have come a long way, they're still not there yet when it comes to really understanding and proving math.
Less than 5% on the USAMO.
Yeah, that's pretty telling.
It really is. And
Yeah.
we saw all those errors in logic and assumptions.
A lack of creativity,
Yeah,
the answer boxing thing,
right.
all of it shows they're still missing something.
And even when they tried to get the AIs to grade, they
Mhm.
couldn't do it accurately.
Yep.
So it makes you wonder, if these super advanced AIs can't handle high-level math proofs, what does that say about, like, what it really means to understand something?
It's a great question. And it makes you think about the future of AI. If they can't grasp something as fundamental as math, how will they handle even more complex things?
It really makes you appreciate the power of human reasoning, doesn't it?
It does.
Like, maybe there's more to intelligence than just recognizing patterns
Maybe it's about knowing why those patterns exist.
and being able to explain it to someone else.
Exactly.
So, it's a lot to think about. But that's what these deep dives are all about, right?
It's the fun part.
Yeah, getting you to really think about the big questions. And who knows, maybe someday these AIs will be proving theorems alongside us.
Maybe. But for now, I think we humans still have the edge in the math department.
Yeah, for now.
For now.
Well, that's all the time we have for today's deep dive. Thanks for joining us, and keep those brains buzzing.
All